DevOps is not tools. DevOps is not tools. That's one thing I want you to know. Very, very important. DevOps is not tools. It's very, very important you understand this. Another thing I want you to understand is DevOps is not, how do I describe this now? Okay. DevOps is not a style. It's not a style. Okay. Now let's just keep it at this. These two simple things. A lot of times when you see people say mention a lot of tools, e.g., in this case, you could see something like what is it called? Jenkins. Okay, there's a tool called Jenkins. Oh, let me see. I don't think this is being recorded. Okay. Okay, it's currently recording. I was thinking I didn't start recording. Okay. Is this the same for everybody? Is it blurred for everybody? Just let me know if it's blurred for everybody so I can just do the necessary adjustment. Okay. All right. So DevOps is not a tool. And a lot of time, most people think you have to know a lot of tools to be able to do a lot of things. So, but that's not the whole thing. There's much more to that. Okay. So in the process of telling you what DevOps is, I'm also going to be talking about the misconception. So it's going to be both of them. Okay. Yeah. For this, yes, I'm going to move over to doing this on Notepad so that the font can be bigger. Okay. So it's fine. I'm going to be writing here, so it's going to be bigger here. Okay. So if I'm doing this, this is, you understand? So this is better now. Okay, so if I need to draw anything, I'll use this. Okay, good. So, before we go on, please, can anybody tell me what do you think DevOps is? What do you, from your experience, you may have been learning for the past 2 months or for the past 6 months, so or even 1 week on your own. Can you tell me what do you think DevOps is? What is DevOps? That's the question. You can feel free to write. You can feel free to unmute yourself and just answer the question. What do you think DevOps is?
All right. Hello. Am I audible?
Awesome. Yes, you are.
All right. Thank you. Thank you very much for this. So actually, DevOps is more of a concept, and thinking of DevOps is the idea. What is the gap that DevOps is actually bridging? That's Dev and Ops. So I would say DevOps is more of concept over tools, right? All these tools, what are the aims of these tools we are using? What do we aim to achieve? To bridge that gap, between Dev and Ops. So I would say DevOps is more of a mindset and a concept. So that will help, that also guides the use of these tools, with the long run.
Okay, thank you so much. Thank you so much. So two things I had is DevOps is a mindset and DevOps is concept over tools. Over tools. Any other person? Does any other person wants to try? Any other person? So we can quickly continue. All right. I feel it bridges the gaps and harmonizes development and operations of a system. Okay, that makes sense. Okay. To bridge the gap, and harmonize, bring them together. Okay, that makes a lot of sense between two different departments. Okay. So the truth is this: if you start learning about DevOps, you will be exposed to a lot of definitions out there, a whole lot of definitions. Okay, so ensuring that products run successfully. Beautiful, beautiful. Now, so let me say DevOps is successful running of products. I can also say DevOps is is the delivery of software. Possible. I think I've had this kind of definition. DevOps is basically delivery of software, right? DevOps is like the bridge builder between people that, who create the software. Okay, I think I like that definition as well. Let's see. Let's see. It said DevOps is like a bridge builder between people who create softwares and people who operate and maintain them. Okay, that makes a lot of sense. That makes a lot of sense. Okay, so let me show you. If you go to just type I think it's word is DevOps. AWS has a model, AWS model. Yeah, I think so. So this is according to AWS, right? This is their definition. It said DevOps is the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. Now, this is evolving and improving products at a faster. Now, this is so much grammar. You understand? So, to make it very short, some people will say that DevOps is the combination of practices and principles, right, to help an organization deliver their products at a high velocity. You can even say that. Okay, so the most important thing I want you to get from this definition is we are going to be getting cultures. Okay, let's do this. So one of the things we are doing is culture, okay, plus word, principles or practice, okay, or okay, principles, practice, okay, and tools, right? All right. So fast delivery, okay, fast software, right? This is, so I'm sure you all can still see this. All right, so from this definition, we got that DevOps is simply the culture plus principles plus practices plus tools will give us the fast delivery. In other words, to deliver a software with a high velocity. Now, what does this simply mean? So that we can move to the more interesting part of it, right? When we talk about culture, what are we talking about? We're talking about things like collaboration, right? Culture can be collaboration, how you relate with people, right? Culture can also be communication. You understand? What's the communication like amongst teams and departments? You understand? So those are the kind of things we mean when we say culture, all right? Because you will always see this kind of things included in definitions about what DevOps is. Once they mention culture, that's what they are talking about. Now, when we say principles, we're talking about the what and the why, okay? The what and the why. But when we talk about practices, we're talking about the how, okay? So see this. So this is the what and the why. See this as the how to do it, what you will do and why you are doing it, how you will do it, and what you will use to do it, to perform this end action. Okay, that's just what is happening here. Okay, so there are a lot of principles. We're going to talk about all those things later. Okay, and practices, we're going to talk about them, but I don't want to confuse you so far. Okay, just understand that every software company wants to build softwares. Okay, they want to help their organizations, okay, deliver softwares to their clients at a very high velocity. Let's use Netflix for instance. Netflix, do you notice that Netflix serves a lot of customers? Amazon serves a lot of customers. Coca-Cola serves a lot of customers. You understand? And these companies, on record time, their deployment is actually in seconds and minutes. They do a lot of deployments and feature changes within seconds and minutes every single day. Now, this might be a little bit confusing for you if you've not done anything about development before. Okay, if you've not done anything about development before, this will be very, very confusing for you. Okay, so but before I do go into other things, right, I want to first of all explain some things and how things used to work back in the day. All right, now let's take a case study, right? Let's say personally I need a website. Okay, I need a website. So I'm the client. I need a website. Okay, and product is going to be what? Website. Now, sorry, this is supposed to be spelled in full. Product. Okay, so the product is supposed to be the website. Now, I need to contact a company to build this website for me. I need a product, right? Okay, let's assume we have I think I saw a female person here yesterday, which is Mary, right? Let's assume that the client is Mary, right? Assumably, and Mary needs to have a design brand. Okay, she's into design, she's into fashion, right? So she wants to build a website where she can showcase all her beautiful designs as they come in, right? Now, we told Mary that she can do this as a company. We told Mary that she can do this. So Mary decides to contact us to build the product, the website that is going to provide that service to her. Okay. Now, when Mary comes to us as a software company, you understand, I want you to know that in a software company, there are usually so many departments. In every company, there are usually so many departments. You can have the IT department, okay? You can have the IT department, you can have the HR department, you could have the finance, you could have the health. I'm correct, right? If you all can relate, just have a mental picture of the kind of departments you will find in a big company, right? They're usually different departments, all right? So in this context, the department that will be responsible for building this product that Mary needs is the IT department, which some people also call software department. All right. Now, this software department comprises of different teams. Okay. This IT department comprises of different teams. And when I say different teams, what am I referring to? I'm referring to those who are going to be responsible for gathering information. Okay, so it can be the business lead. Okay, we can have some people we call the business lead, okay, development lead, okay, or business developers. We could also have some people we call the scrum managers or masters. I'm going to explain some of these things as we move on. We can also have some people that are going to write software, so we'll call them programmers. We can also have some people that are going to do some design, okay, so we call them designers. We also have some people that are going to test some things, we'll call them QA, and so on and so forth. Do you understand? So yes, so these are different teams inside one department. Please, I hope this is making sense to everybody. If you're confused and you need more clarity, kindly let me know and I will buttress further. Okay, now these are all the departments, these are all the teams we have in this department. All right, now one of the things we want to do is to give Mary a very outstanding product. Okay, now there usually used to be what we call traditional do I use the word model now or approach? So we used to have what we call the traditional approach, and we used to have what we call this is also what we call the modern approach. Now, when I say traditional approach, what am I referring to? The way we build application those days where these entire people, right, they are going to follow a a pattern or what we call a cycle. Some people call it SDLC. Okay, sorry, I think I've deleted something. So some people follow SDLC, which is called what? Software Development Life Cycle. Okay, so the way we develop the software, there's a pattern. Okay, there's a flow, steps, set of steps that we will follow to develop the softwares. Okay, so remember that the software or the product we want to build is for Mary. Okay, and in the IT department of my organization, we have so many experienced professionals. Okay, and when we want to build the software, we follow different approaches. Okay, and that approach, which is called what? Software development life cycle, right? There are so many of them. Okay, I hope this is not confusing anybody. So there's something we call agile, there's something we call waterfall. There's so many of them, but I don't want to there's spiral, there's V, and the rest of them, but I'm going to keep it very, very simple. Okay, now just know that this is the approach we are going to use in building the software. Okay, but back in the day, we used to have the developers. Okay, which whenever you hear the word developers, okay, they are the people which are also called programmers. Okay, or software engineers. They are going to write the code. Okay, so these people are going to write the code. Okay, and of course they are going to work with the designers. Okay, so I will still explain all these models later. I want to take it slow and steady so it's going to make sense to every single person. Okay, now, so these developers are going to write the code, they will build everything. Okay, and when they are done, they usually give it to some people. Okay, which is what I didn't put here. Actually, we call them system admins. Okay, system administrators. Okay, or some people, some organizations call them operations engineer. Okay, operations engineer. Back in the days, that's the approach we use. Okay, so the developers, alongside with the help of the designers, they are going to write the code. Okay, they're going to do everything, and when they are done, they are going to give it to some people, which is going to be the operations people. Okay, operations. And remember, I said these operations people are some people have titles like system administrator. Sometimes they have titles like release engineer. Okay. Sometimes they have titles like server administrator. You understand? Sometimes they have titles like SRE too, right? So, but I'll just keep it very simple. So these are the titles, these are different group of people. So the way it works is these developers are going to write their code. They're going to build the code. Okay, so they're going to do the code, right? When they are done writing the code, the next thing they're possibly going to do is they usually build it, and the next thing they'll possibly do is to test it. Okay, now when they are done testing it, they are going to probably sometimes they can move it to some environment. Let me just put it this way to keep it very, very simple. I'm just trying to keep every explanation very, very simple before I move to the complex aspect of it. But before I continue, is this making sense?
Yeah.
If you're in the comment section, can you hear me? Can you all hear me? Is this making sense? Are you confused? Okay,
Yes.
okay, great. Okay, all right, thank you. All right, so let's continue. So, all right, so we will now do something we call deploy. Okay, so now actually, let me just put it like this. After testing it, you do the deployment, and if you want to, those days, There's rarely anything called monitoring anyway, but let's just keep it very simple that this used to be the approach, right? So the developers, so this is the simple approach for releasing a software, okay, to the customer. If I want to release this product, the website, to Mary, this is the steps it's going to take. All right. If you want to give Mary a website, this is the step it's going to take. All right. So there's what we call the build, and there's what we call the code. There's what we call the build, and there's what we call the test. All right. So now see these three aspects as something that is handled by the developers. This is the old approach. Don't forget, I'm showing you the traditional approach. Okay. So see this as being handled by the developers. Okay. But back in the day, once the developers are done writing the code, they've built it, they've tested it, it's working very, very fine. Very fine. They need to deploy it on servers, okay? Where the customers, like Mary, okay? If the developers says is ready, I won't take the code and give to Mary. No, Mary needs a beautiful website she can see. Is that true? She needs a beautiful website she can go and her customers will click and click and click. They will see something they can interact with. Okay, so it's the job of the operations team, okay, which is all this kind of titles that they wear or hats they wear. Okay, so their job is to deploy that software that the developers are done with, okay, to different servers. Okay, just see the word server as machines for now, all right, until we dive deeper. So they will do the deployment to those machines, and when they are done, okay, they can now monitor it. In other words, monitor to observe what is happening. Okay, now, but a lot of things usually happen. This process is not usually smooth. Okay, back in the days, it takes 6 months to 1 year before softwares are being built. So imagine I was the one, I was the company. Okay, let me say company owner, company, okay, or let me use the word bidders. Okay, the word bidders. So myself, achiever, and Mayor, right? So my company, I have my own company, and Mayowa has his own company, right? So we are the one bidding for this contract from Madam Mary, right? We want to build the website. And myself, Achiever, I am telling Mary that I can deliver this product within a very short time. And Mayowa is telling Mary that they need to follow due process and they need to follow all the necessary patterns, and it's going to take her between 6 months to 1 year. And I told, whereas I am telling Mary that, you know what, give me between 3 weeks to 1 month. I'm going to show you something. Friends, who do you think Mary is going to approach? It's definitely going to be me, right? Because I have given her what we call I've given her an estimated time. Okay, in the DevOps terminologies, we call it time to market. Okay, time to market, TTM. But I don't want to confuse you with a lot of buzzwords and terminologies. Okay, so you don't feel overwhelmed. So the time it will get to the market, I told her it's going to be 3 weeks to 1 month. Mayowa is promising that it's going to be 6 months to 1 year. Do you understand? Because our approaches will be very, very different. Everybody wants a website, but the approach we use in delivering that website is different. Do you understand? So that is one of the things DevOps is trying to do. DevOps is combining a lot of principles, a lot of practices to help organizations deliver softwares, okay, or deliver products at a very, very high velocity. Does this make sense so far?
Yes, sir.
Does this make sense? Please, you can type yes on the comment section if you understand what I just said. If this makes sense, just type yes on the comment section, so I'll be sure. Okay, good, good, good. All right. Okay, thank you so much. So, somebody wanted, I don't know if Mr. Habib, you had a question before we continue? Okay.
No,
I
no,
don't
no,
think
I'm
there's a
good.
question.
Sorry, I must have unmuted by
Okay.
mistake. I'm good. Thank you.
Okay, that's fine. That's fine. All right, friends. That's fine. So, friends, so now we've understood some of the things I'm explaining, right? We've seen what the problem is. We've seen the way companies build software, right? I've explained to you that this is how companies build software. Now, first of all, write the code, okay? We're still going to do all those aspects of it practically. And when they're done, they are going to build that code, okay? Then they will test it. When they're done, they're going to deploy it before monitoring it, okay? And I told you that this code build and test is usually done by the developers, okay? And which some people usually call coders or programmers, okay? Or software engineers, whichever title you're calling them, it doesn't matter. The most important thing is you understand their job description. I now told you there's another team called the operations people, which is usually the system admins, release engineers, or server administrators, you understand, or SREs, different titles. Now, so why is Frederick or Achiever promising Mary they are going to deliver within 3 weeks to 1 month, and Mayowa is saying it's going to deliver within 6 months to 1 year? The difference is simply in their approach. Achiever is using a modern approach and Mayowa is using a traditional approach. Do you understand? Now, the traditional approach that Mayowa is using is the operations team will have to wait, okay, until the developers are done writing their code, okay, building it and testing it. So sometimes these operation teams will wait for like 1 month or more, right? They will have to wait for a long time before they are done. Now, so before this developers are ready writing the code. Now, but the next thing is, let's assume the developers finish writing the code. The developers are going to give the operations team and ask them to deploy the software that they are done. Is it not true? Now, the operations team, one of their jobs is to ensure that there is no downtime. What do I mean by no downtime? Let me use an example. Friends, I believe we all use some of us use Facebook, Twitter, Instagram, right? Or WhatsApp. Now, these are social platforms, okay? How do you usually feel when they tell you there's a downtime? It's unable to open, right? Or it's lagging. Some of you feel very disappointed, right? So imagine if for over 24 hours you are unable to access your WhatsApp or your Instagram or Twitter, and after 48 hours you got a notification or they released a report telling the users that they are so sorry. It's because they needed to add a new feature, okay? They needed to add a new feature. That was the reason why there was downtime. I don't know if you get the picture. So the reason why there was downtime is simply because they wanted to add a new feature or they wanted to change their servers. You understand? So one of the jobs of the operations team is to ensure that there is zero or no downtime. Even if it is 100% not possible, there's what we call, there should be a guarantee. Okay, I'm being careful not to throw a lot of words here. Okay, there should be what we call an SLA. Okay, service level agreement. I'm going to take it slow and steady so that I don't overwhelm you. One of the things I want to encourage you in these sessions like this is you can have a small note or somewhere you can be writing. If there's any buzzword I throw, right, and it doesn't sync with you, please do not hesitate to let me know so I can go over it again. All right, please. It's an informative session. We want everybody to learn and understand this in as much as possible. Okay. So, having said that, in the bid of the operations team to ensure that there is no downtime, so they will need to provision what we call the servers. They need to create the servers, okay, that is going to deploy this code that the developers give to them. And sometimes back in the days, just to create the environment, that's the virtual machines, okay, to know what type of memory are we going to use? What's the size of this? What's the processing speed of the CPU? What's the size of the RAM, the hard disk, the storage space? How many is it going to need? All those process of creating the environment can take another 1 month. So do you notice that the developers were done, and it's taking the operations team 1 month plus for them to prepare the environment to do the deployment? So the developers will be angry. Can you please deploy my code? Do you understand? So, and the operations teams will be like, calm down. I'm trying to make sure that this thing is working. Because one of the things that used to happen those days in the traditional approach is that when the developers are done, they usually write something we call a documentation, right? That will instruct and guide the operations team on how to deploy the application. Remember that the developer tested it. It was working on his own computer. Do you understand? It was working on his own computer. So, but those servers, which we call production servers, right, is what the customers are going to be accessing the application from. So they need to be well prepared. They need to be well configured. You understand? So this kind of slow approach from the operation team, okay, and the rest of them makes the whole, there's usually conflict and communication between the developers and the operation team. Okay, so that's why Mr. Mayowa takes between 6 months to 1 year before they can release the software or even make an improvement or add a new feature. Does that make sense? Good. If it makes sense. So I want you to understand that Frederick or Achiever is using the DevOps approach, right? And when he uses the DevOps approach, one of the things that DevOps does is that DevOps brings the developers, DevOps brings the developer, right? The developer, okay, and bring the operations people together. You understand? The ops team, it brings them together and say, okay, you know what? We can actually be the same people. You understand? We can let's stop making this thing together. All of us come together. Let's come together. Okay? Let's combine what you know and I combine what I know together. Okay? Combination of what? Practices, okay? Principles, okay? Tools and culture. You understand? To help the organization work, release products or services at a high velocity. So DevOps is a way of doing things. Somebody actually defined DevOps as a way of doing things with automation written all over it. Did you get that definition? That DevOps is a way of doing things with automation written all over it. Automation simply means instead of doing it manually, you just you write, you follow certain steps or approach to make these processes repeated, self-repeated. You understand? We're going to talk about automation and the rest of them when we get there. Okay, so this is exactly the difference between the traditional approach and what the modern approach. Okay, so I want to believe that so far with the explanation, I've been able to oh my god, no, something happened. Okay, I'm looking for my outline. Okay, I'm sure if I will have to go back to see this. Okay, see the outline here. Sorry.
Stop sharing your screen.
So, oh, can you see my screen now? You can see my screen, right?
Not yet. Okay, yeah.
It's coming up.
Let me know if you can see it.
Yes.
Okay, because I'm surprised because I know I was already sharing it. Okay, so
Yeah, it's up.
okay, good. So now we know what DevOps is and we know why we need DevOps, right? So now one of the things, let's talk about the benefits of DevOps quickly so that I can cover a lot of grounds. So now there are different ways we can see the benefits of DevOps, okay, so that we can understand this. I want us to see the benefits of DevOps from two perspectives, okay? I want us to see the technical benefits, okay? The technical benefits, and I also want us to see the cultural benefits. You understand? In terms of which is something I've actually mentioned, okay? Okay, when I say technical benefits, what am I talking about? We've already mentioned it. We're going to DevOps is going to help us to deliver softwares faster. Okay, DevOps is also going to help us to solve problems. When we say solve problem, we use the word remediation. You understand? Remediation is the key word we usually use. When we say remediation, it's like saying when there's a problem, you will revert back to the previous version. With the help of DevOps, right? If there is a problem in the deployment, right, you can go back to a previous step. Okay, either you revert back to the previous step or you automate it such that it will go back to start afresh. Okay, don't worry, this is going to make sense as we move on slow and steady. Okay, so one of the things I said that DevOps is going to do is to solve problems faster. Another thing is it's very easy to repeat processes, which is the same thing as it's very easy to replicate best practices. Okay, that's one of the things. Another what is it called, benefits of DevOps can actually be instead of developers, one of the beautiful things you should know about DevOps is this. You know, by the time you automate, you make this process very, very fast. And by the time you combine both teams, right, it's instead of fixing problems and maintaining problems or solving problems, you're going to have more time to innovate. That's the difference between current development or the DevOps practices now compared to 20 years ago, 15 years ago. There were less innovation compared to now. There's a lot of innovations now because of DevOps practices. People have enough time to innovate things. But back in the days, it was always one problem to another problem to another problem. So you are always fixing or solving one problem. You understand? So one of the is that we tend to innovate. Let's say time to innovate than solve problem. Okay, so you have more time. So these things I just mentioned here, they are the technical benefits. Okay, these are the benefits that DevOps is going to bring to any organization. Now, sometimes during interviews, you will get this kind of question being asked to you. Okay, you may be asked, so for a company that has never implemented DevOps, trust me, friends, I hope you all can hear me. There are some companies that have not implemented DevOps practices at all, right? They still follow this approach of developers, when they are done writing the code, they give it to operations team to release it. Okay, this is used to be the approach. but some companies still follow this approach, whereas some companies in recent times follow the DevOps approach of combining both of them. Do you understand? So I want you to know that if you want to talk about this in interviews, you can literally tell them these are the benefits, the technical benefits it's going to bring to their teams, okay, when they implement DevOps. All right, go ahead, please. I think somebody has a question. Go ahead.
Okay. Yeah. Good evening, everyone.
Good evening.
Yes,
evening.
I want to call your attention to one example that you cited about remediate solving a problem. There is one. Can you hear me?
Yes, please go ahead.
Okay. I want to bring in one idea from my own experience and then from my colleagues' experience.
Okay.
When deploying a solution to a customer, maybe on a cloud, let's assume on a cloud, yes. There are some ISP, there are some cloud service providers that they didn't have a backup snapshot.
Okay.
So from my own experience and my senior colleagues' experience that I've worked with, when it's deploying a software for any customer on a cloud, usually before he can recommend any cloud for any of his clients, he usually asks for that ISP if they have a backup snapshot. So whenever he's deploying, he can clone the whole image of the operating system and then the application. If there's any issue, we quickly restore back. Can we call our approach a DevOps approach?
Yes, you can. In fact, it's actually one of the best practices which they always inculcate, right? So in fact, to be honest with you, there's rarely any cloud service provider that does not provide snapshots. Okay, I think in AWS is EBS, if I'm correct. It should be EBS. No, it's not EBS, that's Elastic Beanstalk or Elastic Block Storage. Yeah, but I think that is the same. It uses the EBS to do the snapshot, right? So the EBS can be backed up. Okay. Now, in terms of snapshot, in fact, if we when we start talking about virtual machine, you also see that you can create a virtual machine and create a snapshot. For those of you that may not understand in clearer terms, the word snapshot is more or less saying clone. Okay. Imagine the hard drive of your mobile phone, okay, or your computer. If you clone it, it means there are two copies, right? The original one and the one, a copy of it. Okay, a clone is like creating another copy of the original one. Okay, so that word clone, that's just the same thing that in cloud we use the word snapshot. Okay, to create another copy of an existing storage, or just to have a backup copy somewhere. That backup copy is what we call a snapshot. Okay, and to the most part of it, a lot of cloud service providers has this service integrated into them. And yes, in the pipeline, it's always encouraged for deployments or infrastructures to have those features integrated in their architecturing or designing. If you're doing any architectural design, it's always important that you factor all those things down, especially for high availability and scalability. I don't know if this makes sense.
Yes.
Okay. Thank you so much.
All right.
All right. So, having said that, I just hope I've not confused anybody. So one of the things, so other ones that we've talked about, so what we mentioned above there, all those things are just the technical benefits. In terms of cultural benefits, we are talking about things like communication. You understand? We're talking about things like collaboration. We're talking about things like professional opportunities. You understand? So when we talk about cultural, we're talking about communication and collaboration. That's one of the things that DevOps is bringing. But when we are talking about technical benefits, it's this four and many others. I hope this makes sense to everybody. Okay? All right. So the next thing we want to talk about is tools of DevOps. Okay? Tools of DevOps. Friends, I want you to understand as a DevOps engineer, you are going to see a lot of tools, a whole lot of tools, a whole lot. And I'm not exaggerating, but I don't want you to be overwhelmed with the myriads of tools you will see. Okay. And the reason why I said that is because it's not about tools. If you know the problem you want to solve, then you will know the right tool to use. Okay. I want you to have the perspective of what I call the big picture. Okay. I want you to have the big picture as a DevOps engineer. Always have the big picture in mind. Okay. If there is a problem, you were asked as during an interview to deploy a web server. Okay. Or you should create a web server and provide an IP that they can use to access the web server, right? All you have to do is to know what is the end point, the big picture. If you know the big picture, you will know how to break it down in steps to solve that problem. So do not bother yourself about knowing all these tools. Now, these are DevOps tools, as many as possible. Now, you may be wondering, how are all these things DevOps tools? Well, it is. If you look here, you're going to see this is application and build tools. Tools that has to do with application and building. When we talked about, there's something called continuous integration and continuous delivery. Now, those are the principles, but we've not gotten there yet. So these are all the CI tools. There are so many of them, okay? If you come down, in terms of database, you see there are so many tools here. There's so many tools here, okay? So I don't want you to be overwhelmed with all these tools, okay? Please do not be overwhelmed with all of them. There are a lot of tools. If you also come here, let's say, and type DevOps tools, and hit enter. Now, let's use this. All right, good. This is a good one. Okay, let's see. Let me quickly show you something. All right, so did you notice this? So these are huge tools that we have here. Okay, sorry, let me close this. All right, so did you notice these are different tools? Okay, Asana, Box, Draw.io, Basecamp, Trello, different kinds of things. This is for communication. Okay, Jenkins, TeamCity, Travis CI, Circle CI. You understand? For deployments, Google Cloud Platform, Deploy, Release, Heroku, Chef. You understand? Victor Ops, PagerDuty, Blue Jeans, New Relic. All this is for monitoring. Slack. So all these things you see here are myriads of tools. These are all popular DevOps tools. And I don't want you to be overwhelmed with these tools. Okay? So when the time comes, we're going to understand all these things slow and steady. And then we'll be able to know, okay, which of the tools should I use? Which tool is going to get the job done better for me and cheaper? Right? Okay. So having said that, it's very, very important we understand them. Okay? You mustn't know all these tools. I would have said sometimes people will tell you to have depth than breadth. But I think at this point, right, we're going to be doing both of them. All right? We're going to be doing a lot of breadth and a lot of depth. What I mean by that is instead of moving from one tool to another tool, but not discussing them much, as opposed to pick one tool and exhaustively explain everything about the tool and then move to another tool, which of course usually will take time. That's the depth approach over the breadth approach. But we'll be doing both of them simultaneously as much as possible. Okay? All right. So we're going to move to the interesting part of it, which is what I call the life cycle of DevOps. Okay? Now, friends, I want you to understand something which I'm going to explain here. Okay? Now, when we talk about life cycle of DevOps, remember that I had mentioned something here. Friends, did you remember that when I mentioned, there's something I mentioned here, which is called software development life cycle. So remember that this is the approach we use in building software. Okay, so some companies uses the waterfall model, spiral model. I think there's the V model, there's the agile model, and so on and so on. So these are the models or approaches. Some people call it methodology, some people call it model, some people call it framework. So you can call it pattern, whichever one. The most important thing is if a company wants to build a software, that framework or model or cycle is the approach they use in building a software. So if you've never been a software engineer before, right, especially for those of you transitioning, right, if a company wants to build a software, right, so the pattern they follow, the cycle they follow is what we are discussing currently. Okay, so one of them is waterfall. If you type waterfall model in DevOps, or whichever one, either you say what the most important thing is waterfall model, either in software development. So you're going to see something like this. Now, I would have gone to show you, I would have written this by myself step by step, but I don't want to take a lot of time. Okay, we're trying to manage time, okay, so that we cover a lot of things within a very, very short time. Okay, so this is what a waterfall model looks like. For those of you that have not heard about it, I'm going to open this. Okay, I actually have some of the notes prepared, but I prefer doing this in real time than maybe using slides. I don't want to make the class very boring, whereby we're moving from one slide to another slide. That's the only reason why we use this approach, okay? So that on your own, you can see how I am getting this information and be able to do it by yourself. Imagine if I already have the slides and I'm just showing you what I've already prepared before. You see, but most of these things, I say them because of something I know, and some of them I go to the internet to look for them, and you can see the way I am searching for them. These are the skills we want you all to learn. I hope this makes sense. All right, so this is what a waterfall model looks like, okay, or a waterfall approach. Okay, now this software development lifecycle, right, if you notice, it looks like from a staircase. From this step, you come down to this step, to this step, to this step, to this step, to this step. Okay, that's why we call it fall. It's falling down. Waterfall. A staircase. When it rains, it moves from one staircase to another one, to another one, to another one, like that, like that. So that's how a waterfall model looks like. Now, this approach of development, okay, let me try to make it more real for you. Okay, as a DevOps engineer, that you got a job, your first job, or an entry level role, you don't know. The reason why we are teaching you this is because as a DevOps engineer, when you join the team, right, you are supposed to work with some group of engineers. Okay, do you remember this explanation? You're supposed to work with some group of people. Okay, so you could be working with the programmers, the designers, the QA or testers, okay, the business developers. So there are a lot of people that you will be joining in the IT department. I hope this makes sense to you. If you know that you're not going to be the only person, that's the first thing you should know. Okay, the second thing you should know is that company is going to be building a product, okay, or offering a service. I don't want to go into those details because it's either it's a product-based company or it's a service-based company, but I don't want to go into that for now. But just know that the company will either be offering a product or offering a service. Okay, they either have a product or they are offering a service. Now, the most important thing is if there is a software that is built or whichever one that's done, they usually follow an approach. The developers and the designers, they usually follow an approach to build that software. All these IT departments, they follow an approach to build the softwares, okay? And we are saying that one of them is called waterfall. So in some of the business meetings, if you join them, they may be discussing something like this. They may not tell you, okay, we're in the requirement stage or anything. You will just notice that there are different teams that are doing different things, okay? So your job as a DevOps engineer is to have a mental understanding as to, oh, this is what they are currently doing. Okay, I think Emmanuel and Tommy are the managers. I think they are the one gathering the information. I think Tonya and Femi, or maybe Matthew, they are the designers. Okay, they are the one doing some design for us. Okay, so when you are in the meeting, they will be discussing a lot of things. Okay, so it's left for you to have a mental memory to know which of the approach are they using. Are they using a waterfall, or they are using an agile or spiral, or whichever one? Okay, so let me explain this for you, then we quickly move on to other things so we can wrap it up. Now, how does this waterfall model works for companies? Okay, now what this happens here is this. Remember the idea that when Mary comes, okay, remember that when Mary comes, right, Mary is going to tell me or Mayor that this is what I want. I want a beautiful application that I can use to showcase my fashion design brands. Okay, and you are going to the job there. There are some group of people like the business developers, team leads, architects, and the rest of them. Their jobs is to go and discuss with Mary and gather as many requirements as possible. Okay, get a lot of information from her to say, okay, this is what the customer wants. The customer wants the website to look like this, behave like this, have that. You understand? So there's what we call the user requirements. Okay, so that is what she wants. Okay, now what she wants is also different from the market requirements. There are other products out there. Okay, there's certain expectation. Okay, so they are also going to gather what we call the market requirements. Friends, I don't know if this is making sense. Please, I don't want to throw so much information and get you confused. Please, if you understand everything, can you just type yes on the comment section so that we will, I know we are all on the same page. Okay, do you understand what we're doing so far? Okay, great. Thank you. All right, thank you so much. Okay, so now those group of people, right? Remember, the developers are not part of them. Okay, it's just some team leads and the rest of them, architects, business developers, and the rest of them. They are responsible for gathering the requirements. Okay, and I told you the kind of requirements. Okay, the user requirements, the market requirements. They just go and gather a lot of information about the product they want to build. Okay, who has built this kind of product before? Okay, you understand? So they are going to gather all those kind of document of requirements, and then they will create a document. There's usually what we call a user requirement document. Okay, now, and this is after they've done a lot of analysis. Okay, that's what is actually happening here. Now, sometimes if you check some other waterfall model, notice something. This is 1, 2, 3, 4, 5, 6. If you come to waterfall model and check some other ones down here, you will notice that they are not, okay, if we click on this, you're going to see this is 1, 2, 3, 4, 5. Did you see that? This is 5. The other one was 6. Okay. Now, if you are wondering what happened to it, this requirements was broken into 2 here. Requirements and analysis were combined. That's just what I just want you to have a mental picture of what's happening. Okay. So those team of professionals, of managers and business developers, they will go and get the requirements, and after doing some market analysis, okay, then they will give it to the designers. Okay, so in this stage is where they get things like system requirements documents. Okay, they get things like the system requirements document. For instance, okay, this kind of product that we want to build for Mary, okay, what kind of database are we going to use? What kind of for instance, it's a fashion brand that we are building for Mary, right? So friends, I want to ask you, what if what if it was a gaming application that Mary wanted us to build? If it was a gaming application Mary wanted us to build, do you know that the infrastructure, like the servers we are supposed to use, will be different from that of maybe a fashion brand application or platform? You understand? So there's a lot of considerations like memory, speed, and the rest of them if it's a gaming application. So for some of you that usually watch football and you have a lot of sites you go to check the score points and scoreboard, in real time you're seeing a lot of updates reflecting and the rest of them. So it is the kind of infrastructure, there are a lot of considerations they took before building that kind of sophisticated platform. You understand? And all those things are considered from the requirement and analysis phase. Okay, the kind of things you are building, how large, and the customer you are expecting, and the rest of them, all those kind of details is what falls between this requirements and analysis stage. Then when they are done, they give it to the designers. Okay, some group of professionals we call UI designers or UX designers. Okay, user interface and user experience designers. Okay, now it could, or even product designer in most contexts. Okay, so although I don't want to mention so many things, okay, but just know that these people are going to be the ones to design. They can use tools like Figma and the rest of them. Okay, if you've not heard about it before, just know that there's a tool called Figma, Figma. It can be used to design a lot of things. So imagine you want to build a website. So you just design how is this application going to look like? What's the size of the button? Where should this text be? Like this website, they designed the space between this place and this place, the height between this V and the top. Can you see the space between? Why is this transcend in this position? The gap between this and this, the gap between this button and this button. So they did all these designs. Okay, these are done by the designers. Okay, when the designers are done, they will create a design document, a product design document. Okay, and hand it over to the developers. Okay, or coders or programmers. Okay, those coders or developers will be the one to write. They will translate those designs, okay, into codes. So now these designers, sometimes they can have two types of documents: high level design and low level design. Okay, now this is a whole lot of things. I'm using what is it called, real world analogies for you all, so that you will have an understanding. But I could as well keep it very simple and just tell you, okay, the designers will be done and they move to the coding. But if you notice, I'm telling you what is expected at every stage. You understand? So when these people are done and they hand over their design documents, or even they just give them the Figma, they give them access to the Figma, okay, the developers will have experience in translating those high-level design documents, okay, to codes. They will write some codes using different programming languages, okay, Python, Java, JavaScript, and so on and so forth, okay. So once they write the codes, okay, they will give it to some people called QA also have assurance engineers. Okay, but because we're not into all those things, maybe when we start talking about doing software testing, we'll talk about some basic things like that. But just know that these are testers that are going to test that software that the developers has built, and they will compare it to the designers. Okay, what the designers did. Oh my God, is this true for everybody? Is this true for everybody? Please let me know. Can you all hear me audibly? Okay, okay.
Hey, hello. Please, can you repeat like the last 3 or 4 sentences you
Come
made,
again,
phrases
please.
you made? Please, can you repeat the last 3 or 4 sentences or phrases you made? Because
Okay,
I
I
was
will. I will.
Yeah, I
All
think
right,
it's for
I will.
everyone. Was still from coding where you were moving to testing. I think that's where we lost it.
All right, that's fine. Thank you.
And you are
So much for design documents are usually the kind of documents for if it's a large scale kind of deployment or a large scale kind of design. Okay, and we usually consider things like is it going to be for a desktop or is it going to be for a mobile? Okay, and if it's going to be for a mobile, is it for an iPhone or is it for different kind of context, low level designs and the rest of them? So just for now, just keep it that the design documents will be handed over to the coders. Okay, and usually it could be on Figma, or they could just send snapshots or screenshots, pictures. Okay, so and the coders, that's the developers, they are smart enough, they have the required skill to translate those designs into codes. Okay, using different programming languages. That's what we said. Yeah. Okay, they use different programming languages. Now if it's a web application, it's usually HTML, CSS, and JavaScript. All right, let's keep it that simple. All right, when we start talking about building, we'll talk about more. So once they build, they write the code, it will be, and they've tested it, they've done everything, they will give it to the testers. Okay, so the developers are going to code, build, and when they are done, they will give it to the testers. Of course, they can test it on their own too if they are done. They give it to the testers. Now the testers will be the one to test. Now, is this what the coders did? Is it working as per the documentation? Is it the expected quality required? You understand? Is the button, for instance, this button, did you notice that if I hover over this button, it's showing red? Okay, what if this hover button was showing white instead of red? Did you notice that the text will not be showing? The text is white, but the hover button is red. If I remove it, it's white. There's a white button there, but on hover, it shows to red. Do you understand that? If you've done coding before, you see this. So it's only when I hover on it, that's when the button changes to red. You see that? Now, if you've ever submitted something before, you filled a form online, do you notice that sometimes when you submit something, it's going to tell you it's processing something? There are some websites that when you go to, if you try to click on the submit button again, it will disable it. The reason why it disables the button is so that you don't click it the second time. You understand? So all those things are part of so the testers will be testing a lot of things. It could be UI testing, it could be performance testing, it could be database testing, it could be integration testing, it could be system testing. Okay, now I don't want to confuse you, but this can be categorized into what we call white box testing and black box testing. When we get to that point, we will talk about it. but just know that the testers are testing what the developers built. Does it align with the system, with the design documents handed over to them? And also, does it meet the user requirements that was gotten from this stage, from the user and from the market? Do you understand? And when they are done, they now give it to the operations people to deploy it. You understand? To deploy it on the server. Do you understand? So this is what the waterfall model looks like. Friends, does this make sense? This is what the waterfall model looks like. So let me quickly move on to the next one. So if you notice, right? So the next one we have is going to be the agile model. So let me quickly do that. So you see, now let me just use this one so that you will get the analogy. First of all, do I use this or okay? So if I use this, so what you should see here is you're going to see an infinity symbol. Okay, this is an infinity symbol, right? That shows you that this is how the agile method works. Okay, the agile method does not usually go from one step to another. Okay, like the way the waterfall model works. Okay, the agile model works like it's the same, almost the same flow with the waterfall. The only difference there is that it uses a different approach. So see the first thing you have here. The first thing is that the developers are going to code. They are going to write the code. Okay, so they have some team of engineers that will do the research and everything. They will write the code. You understand? After that, they will do some planning. Okay, I hope, am I mixing this? Build, code, plan. Okay, so this is how it works. Sorry. Build. This is code.
Hello, can anyone still hear him? I stopped hearing him. Or is it just
No.
me?
I think it's gone again.
Yeah, I can't hear him as well.
All right.
Sorry, we lost you for like a minute.
Okay. Oh, so what I was just trying to get this picture, right? So I was trying to show the agile. This is what agile looks like. Okay. So agile will simply, you just do the plan. Okay. In agile, you do the planning. If you remember the way the waterfall model works, it's the same thing, but using different approaches. Okay. You do the planning.
Hello, Achiba. I think we lost you again.
Yeah.
Sorry. Can you all hear me, please?
Yeah, sure. Yeah, I know.
No. Okay, good. right? So now this is where we stop. So we've been able to understand how the waterfall model works. So this is what the agile model looks like, right? The agile model looks like this, whereby you plan. When after you're done with planning, you design. When you're done, you develop, you test, then you release the software. Now there's an additional one, which is called feedback. You understand? If you notice in the waterfall model, there is nothing like feedback. There was no feedback here. After the operations team has done the deployment, there is no feedback. Another thing with this is, what if there's a problem in the, maybe there's a the testers observed that there's a problem in the what the developers did. The testers cannot just take it back to the coders. They will have to repeat the cycle again from scratch. You understand? So the waterfall model takes a lot of time. Okay, one of the things I want you to read is, I can send you some links so that you can read about the advantages and the disadvantages of some of this model. Okay, so the current model that is actively in use by organizations is called it's agile. Okay, there's actually a combination between the agile and the DevOps model. All right, so the agile is what a lot of companies use. Okay, the plan, design, develop, test, release, and feedback. Okay, so this is done repeatedly for every feature. Okay, you don't have to wait till the coders are done before you test it. Like, you have to wait until the designers are done before you code. Like that. You understand? And if there's a problem, you have to go down again, check the requirements and analysis, do a design on it, go to the coding and do the testing. You understand? So unlike this for the agile method. Now, you may be wondering, this is agile, this is DevOps. What's the difference? Did you notice something? That this is like one circle, this is another circle. Okay? This is create, plan. You understand? This is package, this is verify. This is release, this is configure, this is monitor. You understand? This is one circle, another circle. If you go back to this and maybe use something like this, you're going to notice that the developer is going to code, plan, is going to, so this is the development, this is the operation. I think there's a problem with this. This is not supposed to be build and code. Okay, so it's going to you're supposed to test. Now there are different approaches. Okay, sometimes people will tell you should test before you build. Some people will build before they do the testing. I think that's the reason between this and other ones you're seeing. Okay, so if you notice, the way this looks is different from the way the other one looks.
I think his internet has gone out again.
It's my Airtel. I think I have Airtel. It's just a switch to it anyway. All right. So we've been able to understand different models, right? So in recent times, organizations combine both the agile and the DevOps together. Okay. Now, but there's what we call implementation. The way the agile methodology or model lifecycle is being implemented. Okay. If you in the real world, we usually use something we call There's something we call Kanban. I hope I'm not missing the spelling. Is it Kanban or there are different framework? Yeah, I think it should be either the Scrum and there are two frameworks that the Agile methodology uses. I want to believe it's either Scrum or Kanban, something like this. If I'm correct, let me see. I can quickly just Google this by pasting it here. Okay, yeah, I'm correct. Okay, so the different approaches in which companies use to implement the Agile framework, right, is called Kanban and Scrum. You don't need to memorize this. You don't need to try to remember the definition, okay? Just know that in real, when the meetings for organizations that uses the Agile approach, this is what they usually do, okay? These organizations that uses the Agile approach, okay, no, this is not what I'm using. Okay, so organizations that uses the Agile approach, it's usually done in something we call iterations. Okay, iterations, and they break it down into sprints. There's usually different iterations. Okay, when I mean iterations, I mean cycles. Okay, now if you watch this diagram, this particular diagram, you see this is a circle. Okay, one iteration, another iteration, another iteration. Okay, now the way it works in real time is this: they develop the manager, or what we call scrum managers. Okay, scrum managers or product managers, depending on who is in charge. They usually have something we call, okay, they can use a tool called Jira. We will explain all this later on. Okay, just know that when you join a DevOps team on a beautiful Monday morning, they will just ask you to join the meeting, right? And when you join the meeting, one of the things they do, they will tell you, okay, we have a stand-up, okay, which is actually one of the things that happen in a sprint, okay, or in an agile methodology. They usually have what we call sprints or daily stand-ups, okay? So that sprint, okay, is organized in a way such that it could be one feature. If maybe the software we are supposed to build, okay, the software we are supposed to build is broken down into 8 features. When I mean 8 features, I mean 8 parts, okay? The login screen, the back end, the processing, different features, okay? Just imagine a simple website and just imagine different kinds of interfaces, how it's going to look like. Just like this one. This is the login screen. This is the search feature. If I type something here and hit the search, it's supposed to search for a result. Is it not true? So there are different features, okay? So the way it works is this: companies usually have different sprints and say, on this sprint, okay, when I say sprint, what I mean is like, do I use the word period now? Okay, and say on this sprint, which usually lasts for 2 weeks, 2 to 3 weeks, or 4. I think the most is 3 weeks, to the best of my knowledge. 2 to 3 weeks. Okay, for 2 to 3 weeks, we are going to be working on one feature. Okay, we are going to be working on one feature, and we're going to need maybe only 3 developers and 1 tester, okay, to work on this feature. You understand? To work on only one feature. And they are going to be meeting every single day, right? Or maybe 2 times or 3 times in a week, right? So they will be having daily stand-ups to check what we call backlogs, okay, to see what they are currently working on. They use tools like Jira, Clubhouse, and what is it, Bugzilla, and the rest of them, even Trello, communication tools like that, to plan and design this kind of a thing. Okay, so this is how an agile methodology looks like. Okay, whereby when they are working on a particular feature, okay, they will implement it this way. Okay, and another team of people So there can be 4 sprints. Okay, so when they are done with this, what is it called? This feature, they will have another sprint again, another 2 weeks sprint to work on the second feature. They will have another 2 weeks sprint to work on another feature. Before you know it, they may need like 8 sprints to work on 8 features, which will be in 16 weeks or so. It could be less. Do you understand? So, but this is what an agile methodology looks like. I don't know if this makes sense. So this approach is different from the waterfall that we explained before, which is this one. You understand? So what I just explained now is how the agile methodology works. And a lot of companies use this a lot. Okay? So in case you join any team and they tell you, okay, we're going to add you to Jira, they usually raise tickets. Okay, if there's something you need to work, you're going to create a ticket. And when the ticket is created, it's going to be assigned to somebody. Okay, and when the person is assigned, the person is going to create stories and the rest of them. The person might not do it, or maybe the Scrum manager might be the one creating the stories and the rest of them. We're going to learn more about these things when we start talking about Jira. Okay, I hope this is not so overwhelming for everybody. Okay, we are still talking about the model. So this I just talked about is called the agile methodology. Does this make sense before I move on? Please let me know if this makes sense to everybody. Are we together, please? Can you all still hear me? I need to wrap up. I know we've stayed longer. Okay, great. Thank you so much. All right, so thank you so much. Thank you. Now, so in combination, so if you notice something, right, you're going to see something here. You're going to see Agile versus DevOps. So did you notice that this is DevOps, right? And this is Agile. So, and it's looking like one Agile, another Agile joined together. So just know that DevOps is actually using an Agile approach a lot of times, right? The methodology, the way you implement using Agile is the same thing, but the only difference is that there's a lot of, how do I put it? There's a lot of best practices and automation being done, okay? We're using a lot of principles. So you can actually read these explanations so that you can understand a lot of things, okay? So, but the most important thing I want you to take home from these things is these 2 things I explained to you. They are approaches which companies use in building softwares, okay? So let's move to the most interesting part, which I want to show you all, okay? Now, this is going to be me. So I'm going to explain the modern DevOps lifecycle. That's what I'm trying to explain now, the modern DevOps lifecycle. So this is me, right? Or this is going to be one developer. This is another developer. Okay? This is going to be another developer. So now this can be different developers from different parts, right? So maybe this developer is working in China, lives in China. This one lives in Dubai. This one lives in Nigeria. Okay? They're all working for the same company. Okay? Now, they are going to write their codes. Okay? So, they are going to write codes. Okay? And, codes. So, let me call it Python code. So, it could be Python code. Okay? So, it could be Python. It could be Java. It could be Java. It could be JavaScript. Or it could be C#, which is .NET. Okay? So the most important thing is you understand what I'm doing. So let's put this to 18. Okay, sir. All right, so just know that this is the language, right? So all right, so okay, now the most important thing is these are developers, right? They've written their code in different languages, right? Now, the most important thing I want you to know is this. These developers, okay, there's usually something we call a version control tool, okay? These developers are going to push their code, okay? So they are going to push their code. Okay, so the same thing, Control D. So Control D. Okay, so different developers from different regions, right? They will be writing their softwares. I know we are out of time. Please give me a few minutes so I can wrap it up. Okay. So now this is going to be a software or what we call a version control tools. Okay. Now all the developers from different regions, okay, they'll be pushing to the central repository. Okay. So it can be on GitHub. Okay. It can be on GitLab. Okay. It can be anywhere. Okay. But just see this as the source code management tool. Okay. Now, this source code management tool is where the code is being stored. Okay. Now, the next thing you need to understand is this. Usually, the next thing that happens is this code will be connected to something we call, let's put this. Okay, so we're going to use this and so this is going to be the build. Okay, so I'm going to Control D. Let's call this. Let's do it this way. So this is going to be Jenkins, or let me call it CI server. CI server. Okay. Let's do this. Control D. We are going to have another one here. I'm going to explain all this carefully so you all understand what's happening. So this is going to be here. Okay, so this can be CD server. Okay, and Control D. We can also have something here, or yeah, let's just put something here. I can put it here. Now you may be wondering, what is this called? This can be for scanning. This can also be for dependency checks. Dependency. It can also be for vulnerability checks. It can also be for secret detection. The most important thing is let's just use one simple tool like SonarQube, okay, for code quality and quality gates. So I'll just put SonarQube or Sonar Cloud, whichever one. Okay, just know that there's a tool here. Okay, now I'm going to connect all of them, and then you're going to have another one. So this is going to be the deployments. Deploy. Okay, deployment server, and then we are going to have okay. So we're going to call this AWS EC2 server. So this is going to be it. So we can have 1, 2, 3. So this is one server. This is another server. Okay. Okay, so these are 4 different servers and it's been deployed from here. So this is what I'm trying to do. I hope this is not confusing anybody just yet. Control D. Control D. Control D, and All right. So now, we have some tools we are going to use here that will be used to deploy. So this can be Ansible, this can be Terraform, this can be Docker. So we're going to take it slow and steady so you understand what's happening. Okay. So this is our CI server. This is our quality checks for SonarQube, and this is our CD. So this is what usually happens, friends, so that you understand what happens for a real DevOps lifecycle. This is what happens as the developers write their code, okay? And they are going to push their code to GitHub, okay? Or any source code management tool. And when they are done, so normally they are going to build it depending on the kind of project. If it's C#, you can use something we call MS Build, okay? We can use MS Build. Let's come here and put this here. We can use MS Build for C#. Okay. We can use what is it called? NPM. Okay, NPM for packaging JavaScript, which is usually Node.js. Okay, or any just JavaScript packages. It can also be Gradle. Okay, it can be Gradle, or it can be Maven, or it can also be Ant. Okay, all these are just different ways of packaging application. I hope this is not confusing anybody. Okay, depending on the application that you are using, if your developers are using if the developers built the application, okay, and store the code on a server, okay, called GitHub, for instance, which we created yesterday. Now that code needs to be built and packaged, okay. And if it's a C# application, we usually use MS Build, okay. If it's a JavaScript application, we usually use NPM. If it's a Java application, we can use Gradle, Maven, or Ant. I hope this is making sense to everybody. Good. Now, the next thing we usually do is this. That application, sorry. All right. Okay, pardon my diagram. So, but you get the, okay, let me just make it look. So this is going here. Yeah, so. All right, so the most important thing is that this is going to be the CI server, okay? So now sometimes it's going to pick it up, okay? And let's do it this way so that I don't confuse you further. Let's do this. Okay, good. So Jenkins, which is the CI server, is going to pick up the code, okay? Once it's done picking up the code, the next thing it does is it's going to choose to build it if we are using Jenkins. Let's do it this way. Yeah. All right. This is what happens. When the developers push the code here, it's going to store the code here. You can use a CI server or GitLab, Travis CI, whichever one. Okay. Then you can use Jenkins to also build if you want to, if you know how to. You can use Jenkins to do the building, and then you can integrate another server like a SonarQube for testing and checking quality code, to check the quality of the code, right? To know if it reaches, it's another form of testing anyway, okay? Security testing. Let's just call it security testing, okay? That code, you do some security testing on it. That's what usually happens here. So let's drag this to this point, okay? So, all right. So the next thing you do is when you are done testing the code and it reaches and you do something like code coverage and the rest of them. If the code reaches a certain threshold of quality, maybe 100% or 75%, okay, you are sure this code is okay. It's free from every loopholes and maybe any form of anything that will prevent exploiting, for any vulnerability that will be exploited. You understand? Once you are sure that there's no backdoor and the rest of them, and all the security checks are good and in place, right? You move to deploying that software, okay? Which is what we call CD, okay? Deliver the software. You can store it in some servers, okay? Some continuous delivery servers can be things like Nexus, JFrog, you understand? Artifactory servers, okay? That's what we call it, in case you hear things like that. Please, can you all hear me? Is this making sense? I know I've taken extra time.
Can you come again on this server?
Okay, so now this is in terms of the CD, right? Where we store the code. Okay, the idea is this. Once we have gotten it from the CI server, okay, which can be Jenkins, which can be GitLab, right? We need to connect it or integrate. This can be integrated anyway. It mustn't be in a different server. The most important thing is that just know that you are going to do some code quality checks, okay? Some scanning. It can be SAST, okay? It can be SCA, source code analysis. When we get to all those points of putting security in our DevOps pipeline or cycle, I will explain all of them carefully. I don't want to overwhelm anybody. That's why I'm taking it slow and steady, okay? Just know that we are going to perform some code quality checks on that code that we have on our CI server, okay? To know if that code reaches an expected quality. Like, that's what we use the word, a threshold, okay? If the expected threshold is being met, okay, it's like a quality, we call it quality gate. Two things that usually happen is called scanning and quality gates, okay? So the quality gate is the rule that says if it does not reach this certain threshold, go back, notify the developer or throw a failure and let the developer knows that this is the problem. You understand? That's exactly what happens here. So I repeat again, two things that usually happen: scanning and word quality gates, okay? And one of those tools that we can be using for all those things is SonarQube or Sonar Cloud. There are many others, okay? So, and remember that I said what we do here is things like scanning, vulnerability checks, secret detection, to know if there's any credential that is not supposed to be there, that's already available in the code. You don't want to be able to expose your passwords and the rest of them, okay? So those are the kind of things we will do here, all right? Now, the next thing we do is that code, if it has passed the quality threshold, right? Or the code quality threshold, we will now store the code somewhere, that packaged code, okay? We'll store it somewhere here, which we call CD. This is done manually, okay? So this not necessarily manually, okay? What I'm saying here is this: once we store that code from the CI server, now the way this thing works is it's not like it is from year to year and from year to year, okay? So this CI server is responsible for pushing it from one point to another point. In fact, the way this diagram is supposed to be is this is how it's supposed to be, and this is supposed to be here. Do you understand? Where this will now be like this, okay? So the CI server will be the one to check the quality code. If it's okay, it pushes it to the CD server, okay? So it will build it, it will check the quality, and to store it on Nexus or JFrog, okay? These are Artifactory tools, or you can even store it in a cloud native tool like AWS Artifacts. Don't worry, all these things are going to make sense by the time we get to those points, okay? I will introduce you to all those platforms and tools, and we will use them, okay? So just know that this is what we call the seed, where we store it. Now, when you are done, right, you can now manually choose to deploy it, or you can set up an automation. There's a difference, okay? We have CI and CD, and we have CI, CD, CD, okay? That's another explanation for when we get to continuous integration, but I'll just keep it very simple. So now the next thing we have here, this is what we want to do. So we are going to deploy it and then deploy it to the server. Now, I was trying to explain. So what we use here, I said this can be Nexus and this can be JFrog Artifactory. Okay. Sorry. Let's say this is 18. Sorry. No, this is 16. Okay, yeah. This is JFrog Artifactory. Control D. So for the deployment, we're going to be using tools like Docker. We can be using Ansible. We can be using Terraform for our deployments. You understand? These are the tools we can use for this stage. Okay, for this stage. Now, okay, let me just quickly do this. Control D. This is going to be Jenkins. This can be Jenkins. This can be GitHub Actions. Okay, don't worry. If you've not understood any of this, don't worry. It makes sense as we progress. All right. So these are tools or platforms with continuous integration. When we say continuous integration, it means pick the code here. So this is going to be responsible for picking the code continuously. Okay, any code that the developers push to this place, this CI server is responsible for picking the code and then testing it. Okay, by doing the to build it, do the testing and deliver it. You understand? CI, CT, continuous testing, continuous delivery. You understand? This is the CI tool responsible for it, the CI server responsible for it. I hope this makes sense. Okay, so then you can now use these platforms or these tools or technologies rather to deploy to a server. You can use Docker, you can use Ansible, you can use Terraform to do the deployment. Now, it doesn't stop here. Now, Mary can view this website now with the help of a public IP provided by these cloud service providers. These are cloud service servers, okay? It can be a virtual machine or anyone. Now, the most important thing is that customers can access these servers using a public IP. Does that make sense? Using a public IP. Now, another beautiful thing is this: we usually integrate what we call monitoring. Do you remember this diagram? This diagram here, whereby you see verification or feedback, right? In the DevOps and Agile model. So how do we implement that? To implement that, what we usually do is we can connect to this server and conduct some monitoring, right? So we can use so let's come here and have something like this, and we can have something like we can use AWS CloudWatch. Sorry, we can use AWS CloudWatch. We can use what is it called, Grafana, okay, and the Prometheus. Hope I'm correct with the spelling. We can also use AWS X-Ray. We can also use something we call New Relics. We can also use something we call Datadog. We can also use Nagios. You understand? Now, you may be wondering, what am I talking about? There's something we call, so products that has been deployed to the servers. I can call Mary and tell her, Mary, your website is ready, and I'll provide an IP for her, okay, with the help of a public IP. So with the help of a public IP, let's do this 16. So with the help of the public IP, I will be able to give this to Mary, and Mary will be able to view the contents of what we've deployed. Okay. Now, but companies usually have something they set up something we call observability, so that they can get feedback from these servers, from these systems they've deployed. If you want to get feedbacks, okay? So you set up something we call observability. You are trying to get a lot of information. What kind of information are they trying to get? They're trying to get things like logs, okay? The logs of the server. What is, if there's any downtime and the rest of them. They're trying to get logs. They're trying to get metrics. And then we're trying to do what we call tracing. Those are the three things that's usually happening here. Okay? 16. So these are the three things that's usually happening at this stage. And now these are the kind of tools we can use for them. Okay? Let's use 14. Okay, this is fine. So you can use CloudWatch. You can use X-Ray for the tracing. You understand? So these are popular open source tools and also native tools that I just put here. There are many others, okay? But I'm just trying to keep it very simple so that I don't overwhelm you with so much information. Now, the SRE teams, okay? Don't worry, when we get to that point, I'll talk about it. But just know that once we set up this thing to monitor these servers, right? This is going to be responsible for monitoring the servers. Let's get this. Sorry. Yeah. So this will monitor the servers, right? And get a lot of feedbacks to it. Now, the next thing they will now likely do is to set up something which we'll call a board. Yes, I will share this. So we can now set up something like, we can use Jira, right? Or we can now create a ticketing system, okay? We can set up a ticketing system whereby if you observe that something is down, right, we can connect it to Jira, or we can send notification to Jira or to Slack, or even send an email. You understand? And the developers responsible will be able to pick up the issue of whatever it is. This is 16. So once they pick it up, they will now send the information back to the DevOps engineer. Sorry. Let's put this, let's move from here to here, and then Control D. This is moving from here back to, so this is, I hope this is not confusing anybody so far. Please, can you all see this? Does this make sense? Do you understand what I just did here? Any questions so far? Please, I want you to have a mental picture of this, because a lot of the things we will be doing will be revolving around this. Okay, so this is the DevOps life cycle. This is exactly what is happening. So for any time you'll be hearing a lot of tools, always have a mental picture to know, where does this fall into? If you hear about a particular tool, ask yourself, which stage does it fall into? Once you have this picture at the back of your mind, you will always know what to do. Okay, somebody's asking a question. I didn't get that still. Let me say, I have a question when you're done. Okay, go ahead, please. Go ahead, please. Go ahead, please.
Oh, I just wanted to be sure you were done explaining the process before. I mean, just in case you answer my question.
Actually, there's more explanations to do. If you allow me, I could go 3 hours explaining just this. But of course, I don't want to overwhelm people. And at the same time, I want to keep it very simple so that we can relate with it. But over time, I strongly believe that I will still add some security concepts and some things to demystify this much more. Okay, but so far, I think I want to keep it simple like this, and then take questions, and we will now see if we've done justice to our outline. So
Okay.
Ideally, there's actually small things here, but I think I've actually taken more time. Please go ahead with your question.
All right. So my question is, you said the developers would push this thing. I mean, push the code, right? And you said it. I mean, it creates an artifact. If I'm right, that's the word. And then these things are given a version, right? So, like, let's say phase one or like chapter one of the application, right? My question is, what if the developers go back to make an upgrade or a change? Still the same application, but like an upgraded version. So what happens? Are you replicating the entire process? And how would this
Go ahead.
artifact be saved? Like, you still want it to remain the same version, to retain the same version number, right? But you just made, like, developer just made a little update to the application. I don't know if I'm making sense, but that's my question. Like, what
Yeah,
process?
it makes a lot of sense.
Okay.
Yeah, it makes sense. Actually,
Okay.
that's a very great question, and it's also going to help more persons here appreciate what happens in the real world. So there's a concept of tagging and release. Okay, there's something we call release cycle and the way product software is being released, right? So now there are different ways I can explain this, but just to keep it very simple, just have at the back, this is how it will likely be, right? When the developers are about pushing the code, right? They could do something they could tag this codes, right? There's a way you can do tagging. We'll talk about all this when we get to GitHub and the rest, okay? The advanced aspect of it. So we can do the tagging, okay? Once we do the tagging, and maybe this is version 1, okay? Now, once that is done, okay, of course, every other push is literally going to be maintain tag v1, depending on the tag you give it, right? And everything, once it's getting to GitHub, which is where you see the tag and the rest of them. So no matter the number of times the developer push is v1 as the version number for your is literally still made. Now, everything the CD comes in terms of the delivery, right? And for every time you pick it and you release it and you store here, of course, you're going to label it version 1, version 2, right? Now, you can actually, the way this thing is, you can actually have different versions, okay, of a particular tag, right? Such that in the Artifactory, you can have more or less like the rollback version. If you've ever had maybe somebody released something into production and then something happened and it crashed, one of the things companies usually do is to go back to the previous roll back to the previous working version. Okay, so the concept of what is it called? The concept of labeling or tagging, right, helps in the idea of how we version our software and how we release them. Okay, and we can use tools like GitHub to help us to manage that. And then if we're working with maybe a monolithic architecture or a microservice, that's a different thing anyway, especially if you're working with Docker and you are trying to containerize it, right? Of course, when you are pushing this Docker containers maybe to somewhere like Docker Hub, right? Of course, there's need for a lot of versioning, right? That can also be factored, right? But just to keep it very simple, right? We use tagging to do the versioning in this angle, and it can still retain the same version number when we store it in our Artifactory. I don't know if this makes sense to you. Can you hear me? Please, does this make sense?
Yeah, it does. Yes.
Okay, all right. Any other question from any other person?
Hello, good evening, everyone.
Yes, good evening, please.
Can you hear me, please?
Audibly, yes, I can.
Okay. So I have this question concerning all these the areas, and from your explanation, I trying to understand the how dynamic those tools that are, I mean, for every stage, how dynamic they are. So from here, is it that there are some of these tools that can do two or more things at the same time? I don't know if you understand that. Okay, yes, I understand that. Yes, there are at the CI level, you have GitLab that can function. That it can also build as well. So
Okay.
is it applicable for every stage whereby there are some tools that can actually combine two or more activities together?
Okay, that's a very brilliant question. And the answer to it is yes. For instance, because we're going to be using GitLab, right? GitLab is more or less like a DevOps ecosystem on its own, right? With Git, you can do the CI, you can do the CD, and you can do the security, continuous testing, continuous integration, continuous delivery thing. It's like I can literally do literally everything. And then, in fact, if we're using just GitLab, you may not even need anything like this, right? You may just have it from here to the servers. You understand? It's that possible. Okay. So the answer to your question is yes. There are some tools or platforms, okay, that has the capacity for performing all this task all in one. Okay. So there are some of them that has just one single function, some of them multiple or dual functions, and that's fine. Okay. For instance, when we start talking about IAC infrastructuring as code, we can use Ansible for infrastructure provisioning, okay, to do, but it's not designed for that. Okay. The ideal thing we're supposed to use Ansible for is for configuration management and not for infrastructure provisioning. It's not that you cannot use it. I can use Ansible to create an EC2 instance on AWS, right? And it's going to work fine, okay? But it's not designed for that. That's not the use. That's your question.
Very well, thank you.
Okay, okay. Any other question from anybody?
Oh, all right. So, hello, can you hear me?
Yes, go ahead, please.
All right. So this is more like a okay. I would still call it a question. So, what I have rather done in the past times mostly is using, or you actually mentioned something similar in the last, in what you just said now, using like one server for both the CI and the CD. So I was asking, using CI and DC, using like two different environments or servers for CI and having just the build artifacts in the CD, right? Is a best practice, but at some point, is it not resource? It's not going to like take much resources in terms of cost now, right? Using like two different servers when one can actually do the build and deploy.
Okay.
Is it
Now,
like a best practice or yeah?
that's a very brilliant question, and thank you for asking. Now, I'm going to use GitLab as a use case, right? GitLab, for instance, provides different services structure. Now, we have the free and the enterprise service, right? Now, enterprise in the sense that you have to pay for it to get a lot of functionalities and features, right? Now, for the free aspect of it, there are certain threshold. There's a lot of you can exceed certain amount of data volume and the rest of them, right? In terms of deployment, the speed and the rest of them, right? Now, if you've used GitHub Actions as well, you'll notice that or even Jenkins, and when you're doing, okay, I don't want to assume that you've used it, right? But just know that some of these tools, right, if you're using the free version of it, right, there are a lot of constraints that are being placed in the amount of response per time, right? And if you have customers in their millions that depends on your service, and you want to be doing a lot of CI and CD continuously, and maybe you have a product that performs a CI and CD operation, you do a lot of deployment, maybe 5 to 100 times per day, right? Now, or even 1,000 times per day. You ideally don't want to use a free service for those kind of things, because it will slow down your builds and the rest of them. Now, there are other open source tools. When we say open source, we mean free tools that a community built, right? There are other open source tools that you can use, right, to do that. Jenkins is actually an open source tool as much as it's also an enterprise tool or a proprietary tool, okay? That's why I say it can be free, it can also be enterprise. So you have to consider your use case, right? If you know that it's maybe it's a profit-making company and you have customers and clients, you have to factor in your requirements. You understand? You have to consider all those things when you're building the pipe before you even start building everything. Okay? Before you start maybe in provision this, you have to calculate the cost, check everything first of all. Just like Facebook. Facebook is not going to be worried or they should use GitLab. Do you understand? You get the idea, right? So they will definitely want to use something that is going to be very efficient, because they will still make their money from the customers. Do you understand? But as much as we want to manage cost of our organization, right? So you can use a lot of tools. You can combine more than one or two platforms. The most important thing is just and the response and another server, it's not it's being calculated. You understand? There are a lot of things we can say on that regards, but there's a pro to it and the con to it. I don't know if this makes sense and it addresses your question.
Oh yeah, definitely. So, because I'm actually more hands-on with GitHub Actions, the premium version. But I just wanted to know, but like you said,
Okay.
is use case dependent, right? For some
Yes.
places where the bulk of the traffic is maybe on the public facing side, you don't really do much CI except you have updates from the development side of things. But like you said, some processes would need to. So it depends on the build or the architecture of the code in general. So yes, that addresses the question.
All right. Thank you very much. Thank you. Any other question? I'm so okay, it should me to use just 1 minute and wrap it up. Okay, so that we can just finish this outline. Or do you suggest we leave this till maybe on the weekday? We'll just come and wrap it up, or let's finish this. Thank you so much, Tejorin. Thank you. So, friends, what do you suggest? Do you or 10-15 minutes, or do you suggest we wrap it up today and then continue?
I'm happy that we
Or we can. Okay, we
Can wrap it
finish
up
them.
now.
Okay,
Yeah.
great. All right, so and when we talk about workflow of DevOps, I think it's literally the same thing, right, that I actually intended to explain here. But when I wanted to talk about the work, what I wanted to talk about here was as regards to in terms of the architecture, whether it is monolith or it is going to be microservice. Now, some of you may not have heard about microservice or monolith. In fact, you don't know what I'm talking about, and that's fine. All right. I promise you, we are going to have a session on that. Okay. Justify and break all those things down. Okay. And make everybody understand what exactly it means when we say microservice or monolith architecture of them. You know, the workflow exactly are we talking about? Okay, now I've already told you how the code can be written. Okay, so when we what I'm trying to talk about in this context is the kind of platforms you can use. So, the developers use VS Code or they use Cloud9. Okay, you can use Cloud9. Okay, I'm not sure why my screen it's disappearing. Okay, so you can use AWS Cloud9 if you want to write code online. Okay, also use so that everybody can have some understanding. Okay, so you can also use AWS code commits if you want to use cloud native tools. When we say cloud native tools, what do we mean? Some companies prefer to use cloud tools for all their processes, right? So instead of writing their code, developers writing the code using VS Code, they can tell them to do everything on Cloud9. Okay. All right, so sorry, Mr. Kano. We'll try to wrap it up very shortly. Okay, we'll try to wrap it up shortly. Thank you for your patience. All right, so just I think the most important thing is okay. I think I've been able to still explain this. What I'm trying to do at this point now is just repeat the same thing. So when we talk about workflow, I think I've done justice to it, both in explaining the life cycle, and I think that's fine. So I won't talk about this workflow. Maybe if I have to dive deep down on it, it will be when I'm talking about other things in the future. Okay. So for the learning part, what I wanted to talk about here has to just do with what is recommended for you to learn. This might look like so much. Please, in your journey, I don't want you to feel overwhelmed. For some of you, this has been maybe 6 months you've been learning DevOps, right? And you realize that you may not have mastered everything here. Okay, now that is fine as well, right? But the most important thing that I usually tell people in terms of the learning part for DevOps, right? The most important thing is just make sure that you have good Linux experience. Okay, very good Linux experience. Okay, you can do a lot of scripting. Okay, you can do some scripting, at least bare minimum scripting. Okay, if you can be able to write some Linux commands and do a lot of things, that's very, very important. Very, very important. Now, the next thing which I usually recommend people to do is to have good knowledge in writing Git. Okay, be very, very good in using Git. Okay, once you're very, very good in writing Git, the next thing is to have a lot of experience writing IAC codes. Either you're using Terraform, Pulumi, or you're using CloudFormation. Okay, so once you have this covered, the next thing which is basically important is learning how to build a simple pipeline, and that can be using GitLab or using Jenkins or using GitHub Actions. Okay, so remember, this is just the learning part. Once you are able to understand how to use Linux, set up some servers, do some basic things, use Git, some structures, and build a pipeline. This is the barest minimum of what you should learn how to do. If you understand very well, doesn't matter the number of tools you don't know. Okay, because a lot of people go and learn the tools, but they don't understand how to do some basic things. Do you understand? So we're going to follow some of this order. That's the reason why I'm telling you that this is the learning part. You understand how to do some basic things, and then you'll be very, very fine. Okay, so before we start going into things like Kubernetes and the rest of them, you should be able to understand these basic things. Okay, now, well, this approach idea might look very interesting. Okay, and that's where if you've heard about GitOps, okay, I don't want to talk about that now in terms of auto deployment, but maybe the time comes where we talk about it. Okay, how we can them. Okay, I just want you to know that there's such a thing as that. students to sometimes you may get the word pipeline engineer. So when you get some jobs, right? When you go to get a particular job and you check the job description, maybe on LinkedIn or anywhere, you might see they need a pipeline engineer. Just know that it's still the same thing, almost the same thing. Sometimes you, with the experience, for SRE, you can also be a release engineer. Okay, sometimes it could be DevOps engineer. Sometimes it can be platform engineer. Do you understand? Sometimes it can be either platform or infrastructure engineer. You understand? But I think these are the popular ones. Please, you can also correct or add to this if you think I have missed some of them. Okay, so when you go to search for jobs or when you start learning more, I want you to know that a lot of the time DevOps engineers wear a lot of hats. Okay, they wear a lot of hats, or they have a lot of skill sets they learn in the process of building an entire end-to-end pipeline. Okay, like this end-to-end life cycle that I just showed you here, it combines a whole lot of experience. You understand? And that's what we're trying to see here. So when you are out there, you can see a DevOps engineer addressed also as a platform engineer. Even though some people choose to separate them, it's literally the same thing in terms of operation and in terms of performance or expectation. I hope this makes sense. Now, so when we now talk about the phases of DevOps, it's actually something I've talked about, phases, or sometimes what we call continuous continuous monitoring. You hear things like continuous testing. You hear things like continuous deployment. You hear things like continuous am I missing it? Which one have I not mentioned? Continuous delivery, integration. Even though I'm not putting it in its own. So there's also continuous I think there are about 6 to 7 of them. Okay, so when you see that these are just the phases of DevOps, the different phases or principles that have been embedded, which is something I think I have also explained in the course of showing us the diagram. So I think I've used enough time. So that's the idea behind it, because what DevOps is not, what DevOps is, why DevOps. I told you about the benefits of DevOps. You understand? And what DevOps is solving. You understand? I told us about the benefits. I also told us about the tools. I showed different myriads of tools that DevOps has, right? Now, I moved on to talk about the life cycle of DevOps, the workflow of the DevOps. You understand? We talked about the learning part, the rules, and the phases. All right. So, any questions so far? I think we've done justice, and this is where we're going to stop for today. This is where we're going to stop for today. We've actually done this to everything we planned. I'm so sorry for the network glitches, and thank you for your patience with me. Please, if you have any question, you can still ask. Other than that, I really hope today's class has been very informative to every one of you. And thank you so